Sum of first n natural numbers is given by n into n plus 1 divided by 2 that can be easily derived from arithmetic progression where first term is 1 and common difference is 1. Sum of square of first n natural number is given by n into n plus 1 into 2n plus 1 divided by 6. Similarly, we can find the sum of cube of n natural numbers. Hello, I am Muskan from Cheenta. Today we will be solving a question from ISI MSTAT 2020 problem number 7. We will see how we derive the formula for sequences and use it to find the limit of a sequence. So in this question it is given that aj of n is equal to summation k is equal to 1 till n k to the power j. So we have to find the limit as n approaches infinity of a1n times a2n divided by a0n and a3n. Let's figure out what are these values. a1n, that means the value of j, the power is equal to 1 from k is equal to 1 till n. That is simply the sum of first n natural numbers. 1 plus 2 plus 3 plus so on till n. And that is given by n into n plus 1 by 2. And as we discussed earlier, we have this from the formula of arithmetic progression where first term and common difference is equal to 1. What is a2 of n? Let's figure out that. a2 of n is equal to summation of all the numbers going from k is equal to 1 to n, k to the power 2. That is 1 squared plus 2 squared plus 3 squared, so on to k squared. Let's derive this formula from telescoping method. That is sum of all the squares of natural numbers. That can be written as r is equal to 1 to n of r squared. We need to figure out this using the telescoping method. Telescoping method is the difference of terms which cancel out and leaves behind just 2 to 3 terms that are easy to solve. Let's see how we can use that approach to solve this. We know that n plus 1 whole cube can be written as n cube plus 3n squared plus 3n plus 1. Moving n cube on this side, we have n plus 1 cube minus n cube is equal to 3n squared plus 3n plus 1. Now let's find the summation where n is from 1 till a number x. So that is n plus 1 whole cube minus n cube, and summation n is equal to 1 till x of 3n square plus 3n plus 1. If we expand this is nothing but 2 cube minus 1 cube plus 3 cube minus 2 cube plus 4 cube minus 3 cube till x plus 1 whole cube minus x cube. This is the left hand side. We see these are the terms that will get cancelled out. And this is known as the telescoping series. Most of the terms are getting cancelled out. We will be left with just 2 terms, that are x plus 1 whole cube and minus 1 cube. Let's figure out what is the right hand side. That will be given as summation of 3n square n is equal to 1 to x plus summation n is equal to 1 to x of 3n plus summation of 1 and going from 1 to x. Now the first term, this term includes what we are figuring out, summation of n square. So taking out 3 common, we have summation of n is equal to 1 to x n square. That is the summation we need to find. Let's name it as s. Plus 3 times summation n of n is equal to 1 to x. That means that is sum of first n natural numbers. That can be written as x into x plus 1 divided by 2. And just the sum of n is equal to 1 to x of 1 or any constant is given by constant times the number of terms we have. So that will be plus x. Simplifying this all, we have x plus 1 whole cube minus 1 minus 3x by 2 times x plus 1 minus x, and this whole divided by 3 is actually equal to the sum we are figuring out. And if we simplify this, we get x into x plus 1 into 2x plus 1 divided by 6. So that's how we can find the sum of squares of first x natural numbers. Now let's use that in our question to find the square of first k terms. So a2 of n is equal to 1 square plus 2 square plus so on till k square is equal to k times k plus 1 times 2k plus 1 divided by 6. And the same method can actually be used to find the sum of cube of n natural numbers as well. So our third part, that is a0 of n and a3 of n, let's figure out these two. a0 of n is simply sum of numbers with power 0, that is k to the power 0. And from the laws of exponents, we know that any number to the power 0 is just 1. So that is sum of 1 repeated n times, so that is just n. a3 of n, that is equal to sum of cube that is equal to 1 cube plus 2 cube plus 3 cube plus so on till n cube, and that is given by n into n plus 1 divided by 2 whole squared. Now just substitute these values in our limit. Limit n tends to infinity, a1n into a2n divided by a0n into a3. Limit n tends to infinity, 1n into a2 of n divided by a0 of n to a3 of n. That is equal to limit n tends to infinity of a1n is n into n plus 1 divided by 2 into a2 of n is n into n plus 1 into 2n plus 1 divided by 6 whole divided by a0 of n is n into n squared into n plus 1 squared divided by 4. Just expanding this square. So from here we can cancel some of the things out. N and n square, n plus 1 squares. So we are left with limit n tends to infinity of 2n plus 1 divided by n into 4 by 2 times of 6. That is 1 over 3. And this can be written as limit n tends to infinity of 2 plus 1 by n times 1 by 3. 1 by n, as n tends to infinity is 0, that leaves us with our answer 2 by. This is how we can use different approaches like telescoping series or multiplying a number by a constant as we saw in the previous lecture. We can find the sum of any sequence using summation, some properties of summation, taking out constants common and all those, and help that to solve a question from limit.